Hello and good morning everyone, and thank you for joining our webinar today, focusing on building a data center architecture to power digital business. So I'm Amy Hammond, I work in the marketing team here at Bytes, and I'm pleased to be joined by Max Brown from Pure Storage, who's going to be presenting the webinar for you all today. Before I pass over to Max, I just want to go through a few housekeeping details with you all. So you are muted throughout the webinar today, but I will hold a Q&A session at the end. So if you do have any questions, just pop your questions in the questions box, which is just at the right-hand side of your screen, and I'll read those out at the end. I'm also recording the webinar today, so I'll send you all a link to the recording shortly after the webinar. And there are a few questions at the end, so if you do have any further feedback for us, or if you'd like to request a callback, just pop that in there and we will be in touch. Okay, so I'm now going to pass you over to Max.
Thank you, Amy. Can you just confirm that my screen's come up?
Yes, it's there.
Okay, excellent. Right, thank you for attending this webinar. So this is going to be a kind of fairly quick whistle-stop tour of the kind of products and solutions that Pure Storage offer, and what is it we actually mean by a data-centric architecture. So I'm sure we've all seen slides that talk about the growth of data and no one's deleting data and things are getting bigger. I think one of the most important things really is that, you know, data is an asset, you know, that where we say that 67% of business say it's so valuable, it should be an asset, because without data, your business is nothing. And, you know, we are all in the business of consuming data, storing data, but also analyzing data. You don't just want to keep the data, you actually want to do things with it to actually gain intelligence from it. So a data-centric approach really, you know, there's no real value in having IT staff that are spending all of their time just keeping the lights on, or they're basically in the data center doing lots of plumbing and cabling. You know, IT staff should be better deployed in kind of the world of DevOps or analyzing the data, and getting value from data is absolutely key. If you're just spending time, you know, dealing with complex server and storage configurations just to literally keep systems running, then that's not kind of where people want to be today. So data-centric approach really is putting in an infrastructure that gives you the ability and time to actually focus on getting value from your data, not just working on specific pieces of hardware. And you know, people like Mercedes F1, you know, if you go on our website, you'll find loads of videos and case studies. But you know, there is genuine value out of what these guys have got with their, you know, when they went from their previous storage systems to Pure. I mean, literally just swapping the storage, not even redesigning or re-architecting their infrastructure, just literally swapping the storage. One of their SQL queries went from 4 minutes down to 20 seconds. And this was also, you know, this kind of compounded with their track time, real-time analysis of what the drivers are doing, went from about 10 minutes down to 4 minutes. So for these guys, you know, they got a genuine competitive advantage. So, you know, you could almost say we do help these guys win races. So in terms of Pure, you know, as it stands, we've got just over 7,000 customers. We've deployed about 17,000 arrays. You can see our revenue numbers. You know, we're publicly floated on the stock market, so you can read our statistics. From an analyst perspective, Gartner Magic Quadrant, for 6 years in a row, we've been in that leader quadrant, you know, up there with all the big boys, and in some cases, you know, ahead of them. And we also have a net promoter score that's one of the highest in the industry. And net promoter score is really a simple way of saying, you know, would you recommend, you know, would a customer recommend Pure to somebody else, kind of unprompted? If you look at the industry average of IT, it's about 30s. In the storage arena, it's kind of less than 20. If you look at people like Apple, they're about 80. Tesla's about between 70 and 80. So 86.6, you know, this is why we have such a huge amount of repeat business and such loyal customers. And if you want to look at some videos of customers talking about Pure, or if you want to read up on some case studies, then go to purestorage.com/customers. And you can read up on what Mercedes F1 are actually doing, how Betfair are using us. You know, people like Investec Asset Management ended up with 4 times as many fund managers due to them switching to Pure. So, you know, we genuinely have kind of transformed businesses. It's not like we've made things 20% better. We've radically transformed the way these businesses work. And all of these customers are repeat customers. Once they're kind of move on to Pure, they find more and more workloads to migrate onto Pure, and it becomes kind of a very sticky product in a nice way. So there's some really you know, kind of principles that we built the company around is, we talk about effortless, efficient, and evergreen. And so effortless, really, it's just got to be simple. Now, how do you prove that something's simple, especially if I'm just throwing a few PowerPoint slides at you? So, if you look at the simplicity of Pure, I mean, storage administration is one task of an infrastructure admin's job. It shouldn't be a full-time job. Looking after storage should just be one small part of what you do. And I think to prove the simplicity, our founder and CTO said that if we design a feature or a product or a solution that requires customers to go on a training course, then we should scrap that solution. And this is exactly where we are today. We do not have loads of end user training courses. Generally, we've got a few online videos that customers can subscribe to, or when the installation engineer goes on site, it takes about 20 minutes and he'll show you how to provision storage. It is that easy. If I compare this to many other vendors that have a list of training courses and thousands of pages of manuals, we don't have any of that. Even if you're doing things like cross-site metro clustering, active disaster recovery, even that takes 20 minutes to set up compared to other solutions where it is an 800-page manual. And also, to make it effortless, you want it automated. Rather than skipping between multiple different GUIs and different screens, if let's say you're running VMware, which the vast majority of people are, you just go into your VMware, your vSphere web client GUI, and everything that you've done there, you continue to do, but there's an extra button that says basically do it on Pure. So you don't even have to have any knowledge of how storage works. You can just kind of hit the Pure button and everything's automated. And lastly, to make everything effortless, our support is what we call predictive. And we see a lot of vendors trying to follow what we've been doing in terms of phone home. But again, we know what your arrays are doing in terms of, telemetrics and health and statistics and performance. So it genuinely is a case of don't call us, we'll call you. We'll spot issues before they become issues and, fix them so that customers don't suffer any problems with the array. So from an efficiency perspective, it's just got to work, right? It's just, again, a data-centric architecture. It's got to be easy to use. I just want it to work. I don't need to think about lots of storage configurations. So there aren't any kind of knobs or dials. There's no tuning that you can do. There's no kind of sliders that you move around to get different performance. And also all of our data services are permanently turned on. So what I mean by that are things like data deduplication, data compression, data encryption. They're not things that you have to decide to use, or should I dedupe this database or should I not dedupe it, or should I compress it? These things are always happening, and the array itself will make the right decisions as to what kind of libraries to use to do specific types of compression or dedupe. Again, if you look at many of our kind of competitors in the market, they do also have a level of dedupe and compression, but you have to decide where to use it. And if you just use it everywhere, you're probably going to get some performance hit. We decided to make our array to give you the best performance and sub-millisecond latency with all of the features turned on. So it's not something you ever have to worry about. It just happens. And also, do what you like when you like. So, the way I kind of talk about Pure is predictably predictable. So let's say that you need to do a code upgrade on the array to take advantage of some of the new features, or our support guys have found a potential bug and they want to put a patch on the system. When we do these upgrades, it has no impact on performance of the array. So your applications won't even know it's happened. So rather than spending months planning an upgrade because there's going to be possibly not an outage, but there could be some noticeable performance impact, that doesn't happen with Pure. There is no performance impact. So in other words, we do have a lot of customers that will do code upgrades on their production arrays in working hours because they know it won't have any impact on the applications. And again, that's the key thing. A data-centric architecture, this allows you to focus on your data. If you're having to spend 2 weeks planning because your performance is going to drop by 50% when you do an upgrade, that's not focusing on the data, that's just focusing on the hardware, and it's kind of making you a slave to your technologies. And then the last bit with Evergreen, right? Don't waste money. To be blunt, I think a lot of people in IT have wasted money for the simple fact there's this thing called a tech refresh, which, we do it with our laptops, we do it with servers, we do it with switches, that every 3 to 5 years or whatever the lifespan is, that technology becomes old and you have to throw it away and buy new technology. And we just wanted to, we came to market with a very different approach. So our Evergreen approach, and I'm going to go into a bit more detail on this, is the concept of never rebuying something that you already had. I mean, if I was to use a kind of a commonplace analogy to this, it would be if you think how a mobile phone contract works. Every 2 years you get given a new phone. Hopefully your cost stays roughly the same. We kind of applied that principle to storage. It's something that people have never done before. So we don't have any hidden costs. All the software is included. So, you know, if you were to get a quote from Bytes for Pure Array, one line is the hardware, one line is the support, and then another line will be their, you know, their installation costs. But that's it. We don't charge for any of the software, whereas other vendors will say, right, if you want to do DR, £1,000 per terabyte or whatever. We don't force customers into taking new arrays because we kind of replace the some of the components of your existing array to make it a new one. So we literally make your old array become new to the point where you never have to buy an array. Because this is the situation that most customers have been faced with, with you know, whether it's hardware or servers or switches or even storage has been the worst. Generally, you'd buy another vendor's storage array with a 3 or 5 year support contract. At the end of that support contract, let's say, you know, you get to the end of year 5 and you still want to keep that vendor's array, your support costs are likely to go through the roof, probably 40 to 50% uplift on cost for years 6 and 7. So suddenly it's got really expensive to support an array that's getting a bit long in the tooth, because that vendor actually just wants to sell new hardware. But even if they make it kind of, you know, they make it fairly cost efficient to buy a new array, you know, let's not forget the soft cost behind this. So you are going to run both arrays side by side for at least 6 months to do data migration, regression testing. You know, you're then paying support on 2 arrays. You're paying for 2 lots of switch ports, 2 lots of power and cooling, 2 lots of management. It's just a mess, right? Nobody enjoys doing data migrations or tech refreshes. So Evergreen Storage, if we dig into this a bit, so the first thing that we do is that our support costs are flat forever. There is no point at which we hit a specific year and say, right, next year your support costs are going up 40% because it's year 6. We just don't do that. So if you want to know what the costs of your support are, the cost in year 1 is the same forever. The support costs specifically are tied to the amount of capacity. So if it's £10,000 to support 100 terabytes, it would be £20,000 to support 200 terabytes. I mean, I'm just literally making up some simple numbers there. But again, there's no point where we say, okay, you've hit year 5 or year 6, your costs go up. That just doesn't happen. So number one, you've got very predictable support costs. There's no point where we're going to suddenly increase that. But then to make it even better, every 3 years, we upgrade the controllers. So in other words, you get to the end of year 3 and you make another 3-year commitment to support, like, you know, with your phone, you do a 2-year commitment. With Pure, it's a 3-year commitment. So get to the end of year 3, make a commitment to years 4, 5, and 6, and we will upgrade that array. We basically replace the controllers because that is the brains and the heart of the array. So upgrading the controllers every 3 years means that the array that you buy today literally never gets old. It never gets so old that you have to buy a new one. So you could in some way say that your array lives forever because your support costs are flat and we're going to refresh the controllers every 3 years. And just as a kind of a nice little segue there, we release new controllers roughly every 12 to 15 months. So you'll be going multiple generations ahead. Most other storage vendors tend to do a refresh every 3 to 5 years. We're doing it almost every single year. And we support everything forever. We don't have any strange warranty terms where, you know, if something fails in year 7, it's not covered and you're going to have to buy a new component. That's not the way we work. We just said that's unfair on customers. So if a component does fail in year 8 and, you know, it's not covered by the warranty of whoever we get the components from, it doesn't matter. We do not pass that cost onto the customer. So just to summarize this Evergreen Storage, you know, the TCO is absolutely huge when you look at Pure. The easiest way to do this is if you are looking at Pure and you're looking at other vendors, just ask the other vendors what happens in year 6, because I guarantee they will not give you a 6-year quote for support off the bat. They'll give you 3 years or 5 years, and you know that in year 6, in reality, they want to sell you a brand new array, which is another big CapEx investment. It's data migration. It's just messy. With Pure, year 6, same cost as year 1. And at the end of year 6, we're going to make the array even better and faster. You know, some of the largest banks that we dealt with did their own TCO analysis and said that by, you know, moving to Pure, they're going to save 130 million over 6 years because they were doing the traditional tech refresh every 5 years, buy a new array, and it was a kind of rinse and repeat message. So if you look at what we've been doing since day one, the first array that came out in early 2012 through to what we've done now, because again, this is not revolution, this is just evolution. The let's say the SQL database that was living on the array in 2012 on some 128 gig SSDs, that same SQL database is now living in 2018 on a much larger, much faster array. But from an application perspective, it never saw any downtime, it never saw any application performance hits, but it's gone through multiple iterations of hardware and software and, you know, features and functionality. So if you just think, you know, what storage did you have in 2012? What are you running today and how did you get there? And from 2012 to 2018 or 2019, I bet you've had at least 1 or 2 data migrations, tech refreshes. You may have even changed vendor, which meant all your scripts changed. You had to relearn things, recreate new runbooks. With this is almost like the cloud approach. You know, if you put data in the cloud, the hardware in the cloud is changing constantly, but your applications don't see that happen. This is exactly what we're giving you with Pure. Once you're on Pure, you will never do a data migration. And every 3 years, we will make your technology better without it actually costing you any additional expense. So as I mentioned, you know, the arrays phone home every 30 seconds. We get lots of metrics. And from this, it gives us a lot of insight into what our, you know, what the fleets of arrays are doing. And we can then do predictive kind of machine learning and deep learning on that data to predictively see, could this customer have an issue? Or is there some strange anomaly that's happening on these specific types of arrays? Or have we just spotted a bug in a certain version of code? And if we have, our support guys would open a case, contact the customer, and, you know, come to a resolution, which could be a patch or an upgrade or something else they need to look at. But ultimately, we don't get customers phoning Pure and saying something's just gone wrong. We will spot something way in advance of anything actually going wrong. But we've also taken all of this data that we've been using internally and we give it back to the customers in a very nice, easy to consume format so that customers can do their own workload modeling. They can simulate what would happen if my Oracle database got 3 times bigger. You know, let's look at my VMs. You know, can I correlate what my VM is doing and what my ESX hosts are doing compared to the storage? So we can correlate entirely through the stack to do analytics on virtual machines, data stores, ESX hosts, and actually the array itself. Plus, there's lots of performance analytics we can look at, and, you know, we can drill down into kind of global dashboards to get a quick view of which arrays are going to fill up the quickest. So taking all of this data and giving it back to the customers means customers can do their own analytics and their own kind of workload modeling. So in terms of the products we have, we kind of address a couple of kind of main use cases with storage. On the left-hand side, we're addressing, you know, what would be the block-based storage, so generally Fiber Channel and iSCSI. So this is your kind of VMs, databases, etc. And then on the right-hand side, we've got kind of file and object-based storage for high-performance compute. So I'll just drill a little bit into each one of these. So the flash array, you know, kind of our approach to this, you know, this is our array for block-based storage, and as you can see, the little logos over there, you know, VMware, SQL, Oracle, Hyper-V, etc. Those kind of environments. And we've taken, you could say it's like an Apple iPhone approach. You know, if you walked into an Apple store and said, can I see all of your different phones? It's basically the iPhone. They've got one phone, but it comes in multiple different flavors and sizes. And that's exactly what we have at Pure. So whether you're starting with the X10, which is about, you know, 30 to 50 terabytes usable, all the way through to the X90, which goes up to 3 petabytes usable, pretty much these arrays all do the same thing. They all run the same code base. They all have the same features and functions. It's just that the X90 is a lot more powerful and can actually handle more data than the X10. What we don't do is have different models, because I'm pretty sure that most of our vendors, if they put up a slide that went from 50 terabytes to 3 petabytes, there'd be anything from 3 to 6 different storage arrays, all of which are entirely different. They just have that vendor's badge on. So again, you'd be doing data migrations, you'd be changing technologies. With Pure, that doesn't happen. And even if you do outgrow one model and need to go to the next model, the way we do this, it is a data in place upgrade. We wouldn't kind of, if you had to go from an X20 to an X50, we literally swap the controllers on the array as it's actually running, with, you know, the applications running against it, with no impact on performance. We don't actually bring in an X50 and say, let's copy the data over, because your data stays in. If we kind of look at, you know, we fit with the flash. So in that middle bit that says tier 1 performance, that's what we've been doing traditionally, from your kind of 50 terabytes up to 3 petabytes for your typical tier 1 critical workloads. Then above that, for the highest performance, we've now added some Intel Optane technologies into our largest arrays to give even better performance. So we're using Intel Optane as a read caching layer. So now we're getting much, much faster performance out of the array. But then also we recently introduced the Flash Array C at the bottom layer, which is capacity optimized. So this is slower than the Flash Array X because it's using QLC based flash, but it's roughly half the cost. So now we can get into tier 2 storage for people that want to do large test and dev environments or archiving. So again, we're covering off the tier 1 performance, the ultra high performance with Intel Optane, but also capacity optimized workloads. But again, everything is still 100% flash. The Flash Array C is exactly the same as the X in terms of features and functionality. It just uses different storage medium and has a different performance level. In terms of protecting the arrays or protecting the data, starting on the left-hand side, we do everything from just simple local snapshots. And you can take up to 50,000 snapshots. They don't have any impact on performance. Take as many as you like. These snapshots can also be orchestrated by people like Veeam or Veritas or Commvault or many other vendors that can talk to our API, take snapshots and back them up. But also we can do things, if you want the ultimate in HA and business continuity, you can have 2 arrays and then basically cluster them together or cluster certain LUNs or volumes together. So with this, this is kind of your metro clustering type functionality. As long as your network between the 2 sites is sub 11 milliseconds round trip, which is actually quite a long way, then you could do active-active clustering between them. So if one array was to go down, if you had your cross-site SAN connected correctly, then your applications wouldn't actually see any impact on performance. They wouldn't see that an array has died because it's active-active both sides, whereas most kind of site-to-site business continuity solutions are active one site and then not active on the other, or it's read-write one side and read-write the other. With us, it's read-write at both sides. It's truly active-active. But then if you needed to do replication over a longer distance, or you've got a higher latency on the network, we can send remote snapshots on a periodic basis to any other device. So we could be sending them to another Pure array, we could be sending them to a FlashBlade, or we could send them to any NFS device. And we can now take snapshots on the Pure array and send them to AWS S3, or we can send them to Azure Blob. So rather than keeping lots of snapshots on the array itself, you could store them remotely in the cloud. So let's have a quick look at Cloud Block Store and where that kind of fits, because this is our offering inside AWS. And I guess the easiest way to explain this is the Flash Array that I've just talked about. It's basically a software appliance version of that. So it's exactly the same architecture. It has 2 controllers, it has flash drives. The only difference being it's built on AWS infrastructure. So we're using EC2 VMs as the controllers, and we're using instant storage as well. We're using EBS, we're using S3. But from an end user perspective, it looks exactly the same as a physical flash array. It's just we've built it on Amazon infrastructure. So it is a 100% software appliance. What we chose not to do was to put a physical array in an Amazon data center and then say, there you go, we're in the cloud, because that's not really an answer. We are using the cloud capabilities and the cloud infrastructure to build our virtual appliance. But you're getting all of the efficiencies. So you're going to get things like deduplication, you're going to get compression, you'll get thin provisioning. Whereas, if you look at the cloud, it's almost the opposite. The cloud does a lot of thick provisioning. So if you provision a 100 gig volume in EBS, then you're pretty much going to be paying for 100 gig straight away, whether you use it or not. Now, we stopped doing that on physical storage arrays about 10 to 15 years ago. However, the cloud still does it the old-fashioned way, which means literally the minute you provision storage in the cloud, you've wasted money. Now, if you were to provision that 100 gig LUN from within Cloud Block Store, because it's thin provisioned, it takes up no space on the back end. And when you do actually write data to the pure volume, that pure LUN, that 100 gig LUN that I mentioned, then we will be doing dedupe and compression to make it even smaller. So you are going to get some savings on the back end of the actual AWS infrastructure that we're using. But also, we are actually bringing enterprise class storage into the cloud. So, we can get really good performance in the cloud because we can aggregate across multiple EBS instances, or using GP2 or using IO1 SSDs for performance. Plus, we can give you better uptime. So in Amazon speak, they have something called an AZ, an availability zone, which is basically a data center. and you'll have at least 2 or more availability zones within a region. So these availability zones, as I mentioned, they are just quite simply data centers with a very high speed interconnect between the two. So we could use our active cluster, which is our metro clustering technology, between the 2 availability zones. So if one availability zone was to go down, and it happens a couple of times a year in certain regions, if that went down, your data is already running and is serviceable in the second availability zone. So we're actually giving you better availability than what AWS would natively be able to provide. As I mentioned, the data is always thin provisioned, it's deduped, it's compressed, so that's going to have some savings on the back end for customers that are using Cloud Block Store. And also, because we do dedupe and compression, if you took, let's say, 10 copies of a 60 gig database, in Amazon, that would take up 600 gig, and that's what you'd pay for. In fact, you'd probably pay for more because you'd have to probably provision a terabyte's worth of space. So every time you create copies in the cloud, it will cost you money. However, if you're creating copies within Cloud Block Store, which is basically the pure virtual appliance in the cloud, because we do dedupe, when you say copy something, we will never make a copy, right? It's just all metadata pointers. So your 60 gig database and 10 copies, the second you hit the button to create 10 copies, you're still just using 60 gig. The only data that would accumulate would be unique changes after that, as you start to change these test and dev instances. So you may end up with 10 60 gig databases that actually take up maybe 70 gig, 80 gig. So again, huge savings there. And also one byproduct is all your data at rest is encrypted. That's just something that's natively built into Cloud Block Store and Pure FlashArray by default. So let's touch on FlashBlade quickly. So FlashBlade is where we're looking at the file and object space, but not file for user directories, but file as in kind of generally NFS type workloads, high performance compute. To give you an idea, what customers are using FlashBlade for, they generally use it as a consolidation platform for multiple use cases. So we have some customers that are using it for rapid restore, so use it as a backup target. But for those customers that are doing lots and lots of restores, they might have SLAs against it, they might be doing restores for test and dev purposes, and they need it quick. FlashBlade is the perfect answer. Or maybe they're migrating their data warehouses. So if you're doing Oracle OLAP type workloads, then that would be a perfect fit to move those onto FlashBlade. And then if you look at some of the analytics that customers are doing, you look at things like Elasticsearch, Kafka, Splunk's obviously a very well-known name. Then if you're doing lots of streaming analytics, then you do need a lot of performance around it. And this is where things like Splunk's Smart Store architecture fits very well with FlashBlade, because they've decoupled their indexer servers from the actual data. So deploying Splunk using FlashBlade means you will use about 5 times less physical hardware to deploy your Splunk environment, plus you're going to get better performance. If you look at data lake architectures like SAS or Apache Spark, or even things like HDFS, that tends to be lots of 1U pizza box servers, hundreds of them all clustered together, which again just gets messy because you're doing multiple copies of data. It's a lot to manage, whereas you could have a lot fewer physical servers and have all of the storage as an NFS mount point off FlashBlade. So again, it's a very easy way to consolidate your data silos. If you're looking at any type of DevOps, continuous integration and continuous development pipeline, then generally that tends to be lots of separate environments. However, you can store all of those environments on FlashBlade in order to basically unify and share that data. So one thing that we've had for a while, but we've actually kind of really launched it quite big in the market now, is doing something called Pure as a Service. So there's 2 ways that you can procure Pure, obviously, and this is all through our partners, so Bytes. You can buy it as a CapEx model with support, which is kind of the traditional way, or you can consume it as a service where you pay per gigabyte. And when you're consuming it as a service, this could be whether you're doing it on premise or whether you're doing it in the cloud. This works across all of the kind of Pure products and solutions that I've mentioned, but it kind of de-risks a lot of your work. If you have a workload that is very spiky and peaky and you don't really know how it's going to grow, that might be a reason that you don't want to commit to CapEx, because you may not need it after 2 years, or suddenly it's going to go through the roof for 3 months and then drop back down. This is where Pure as a Service would fit really well. You make, I think it's a 100 terabyte commitment over 12 months. That's the minimum. And you'd pay a certain amount per gigabyte for that. And then if you went above 100 terabytes, you pay, an overage charge, a bit like the old mobile phone contracts. But again, it gives customers the flexibility that if they know they're going to have 2 months of the year where they're going to use twice as much capacity, but that's it, then Pure as a Service is perfect, because you wouldn't really want to buy twice as much capacity just for 3 months, because then you're kind of stuck with it, to be honest. But the way the contract works, Pure as a Service, it's one contract for everything Pure. So whether you've got 100 terabytes on premise and 50 terabytes in the cloud, you would just see one bill for 150 terabytes, and you could move the data between on-prem and the cloud, and it's still one individual bill where you're paying per gigabyte. So just kind of wrapping up a bit, coming back to these 3 core principles of effortless, efficient, and evergreen. And this is the kind of thing that does give you a data-centric architecture. You can focus on your data and get value from your data, because you're not spending hours and hours working out what drives to put in what LUN sets and what RAID sets and what groups and what aggregates do I have to configure. And I'm not spending 3 days trying to work out how to do cross-site clustering, because I can do it in 20 minutes. So again, that effortless side of things mean you're, on average, compared to some of the giant monolithic arrays from the big name vendors, we see a 5x reduction in manpower in terms of, how long does it take to do something. And plus, that we're watching the array for you, that Pure one, I can't understate how important this is to customers, that basically we've got your back. We know what the array is doing. You're not going to have to worry about, will it go wrong? Is something going the wrong way? Because we'll spot that, right? So you just don't need to worry about anything on the array. From an efficiency perspective, as I said, it just works. Data reduction is something that every all-flash vendor will talk about. We have got the best. I'm not going to go into the algorithm right now, but we can prove that either explaining how it works, or in a proof of concept, go head to head. But it's also always on, right? We don't want customers having to make decisions. Should I dedupe this database or not? Would it work better with compression? I'm not too sure. How about if this thing just works and it does it itself? It knows when and where to do it and how to do it. You don't have to think about it, which also means you can run what you like when you like. Again, if I went into the architecture, it's kind of very simple to see that even when we have hardware failures, the performance stays the same. So if performance stays the same and I've had, let's say, a controller failure, then that means I can do things like controller upgrades, whether it's a code upgrade or a physical upgrade to a bigger controller. You can do all of this work with no impact on your applications, which again means you can focus on your data. You don't have to worry about, planning an outage or planning for reduced performance for half a day while an upgrade goes on. With us, the upgrade will take, less than 30 minutes and your applications won't even know it's happened. And lastly, the evergreen piece. It's quite a weird way to start a conversation. If I say to a customer, I'd love to sell you a Pure array, but I will never sell you another one to replace it. Because to be honest, in the history of hardware, I don't think any hardware sales guy has ever said that. It's generally, I'll give you a call in 3 years or 5 years, because you're going to have to rebuy that all over again. It's called a tech refresh. That's not the way we work at Pure. The array that you buy today, every 3 years, we refresh the controllers. It basically becomes new. So there's no point where you would ever have to say, I need to buy a new Pure array to replace the old one, because the old one becomes new. And there's also the ability to consume it as a service. So you could just pay per gigabyte and let us worry about the hardware and what we need to do to upgrade it or provide capacity, etc. So again, it's these 3 core principles that really do allow you to have a data-centric architecture. Focus on the data. That's what is the most important thing. So just kind of final slide in terms of the products that we've talked around. So the flash array, it's our block-based product. We've got the X, which is your typical tier 1 production environments, with flash array C for your tier 2 lower cost environment, but also it's not as fast because we're using QoC flash. You've got your FlashBlade for your HPC workloads. So everything from, if you're doing any type of data analytics or big data workloads, or, you need to do rapid restore. Again, this is a perfect consolidation platform for that. And then also we have our cloud data services. So Cloud Block Store is basically FlashArray running as a software virtual appliance in AWS, but it's bringing all of the enterprise class storage features to the cloud. So we literally make AWS better than what it is today, but we're still using their own technologies, but we're applying enterprise class features and functionality to those cloud environments. And then in terms of consumption, you've got the, they've got the typical CapEx model, but the evergreen means that it's CapEx on day one, and then it could literally be OpEx forever. You're not going to have to go through a tech refresh, a data migration, and rebuying the same old thing every 5 years, or you can consume it as a service and pay per gigabyte. And all of these solutions, the FlashArray, the FlashBlade, Cloud Block Store, etc., they all feed into our Pure One, which is you know, kind of the monitoring tool, the phone home tool. It's what our support guys use. It's what we've opened up to customers, so then they can, you know, use the kind of the workload analysis tools, so customers can model what if scenarios. You know, this is quite key for retailers coming up to Christmas. What they want to model is, what if my you know, my databases grow by 2x over the Christmas period, or how is my data going to grow, you know, for the next few months? Am I going to run out of space in the middle of December? You know, you could do all of this planning and all of this workload analysis and simulation in September, and then spot that you could have an issue in December or January. So then put your purchase order in October, get it all installed, so that when you go into your change freeze from November to January, you know that you're not going to have anything that's going to catch you by surprise. So with that, we're at the end of the presentation. If anyone's got questions, if you want to type them into the chat box, and we can just see if there's anything come up.
Thanks, Max.
Let's have a look. Okay, so I've just got a question that just came in, and it was around on one of the previous slides. I talked about on the slide it mentioned NVMe, and someone asked, you know, what is the importance of NVMe to storage? So within storage, most storage arrays, this is kind of an internal thing at the moment inside the array itself, but the protocols that we've been using for storage, we've been talking SCSI over SAS, which is generally, you know, it's a very kind of old technology from like 20 or 30 years ago. A lot of storage arrays now trying to adopt NVMe, and we were the first vendor to have 100% NVMe. So what it means internally in the array, we're now talking NVMe over PCIe, which means there's much lower latency in the array. And we've now extended that outside the array. So for certain operating systems that support it, you can now do NVMe over Fabric, which means you're getting almost kind of direct access speeds, but you're still using a SAN. So NVMe is something that all vendors are working towards. We've had it in our array since 2015. You know, when customers had their 3-year refresh, they went from SAS controllers to NVMe controllers at no cost. So even then, they were getting bigger, faster, newer technologies without having to buy something new. Whereas all of the other vendors tend to come out with a new array that is NVMe based, which would be a new CapEx purchase and a data migration, and it goes on. I think that's all the questions we had actually, Amy.
Yeah, I'm just having a look to see if any have come through this side. I can't see any. So thank you, Max, for presenting today, and thank you everyone for joining the webinar. I hope you found it valuable. As mentioned at the beginning of the webinar, there are a few questions at the end, so if you would like any more information, just pop that in there. I'll also be sending you all a link to the recording this afternoon. So thank you everyone, and enjoy the rest of your day today. Thank you.
Thank you.